Here we are on Chapter 11, Section 6, and we are going to be comparing surface areas and volumes of all the shapes using proportionality. We're going to be finding surface area and volumes using proportions. And for this to work, we need to know that all of the sides are proportional. So we would start out by saying that 2.5 is to 1.5, and as 3 is to 1.7, as 6.2 is to 3.4. And if I simplify those on my calculator, I get that they do not simplify to the same ratios. So we're going to say that they are not similar. And so none of this process works unless they're similar. So we always check to see if they're similar first. On this one, let's check to see if they are similar. And so I would say that 4 is to 9 as 12 is to 27. If I do my cross products here, I get 108 equals 9 times 12 equals 108. So when I do the cross products and they come out to the same number, then they are similar. So if they are similar, then we know that this proportionality will work. So we're going to say that these are similar. Here we're just determining if they are similar, so I'm going to say 12 is to 15, as 8 is to 10, as 6 root 2 is to 9 root 2. Simplifying here, it looks like if I divide top and bottom by 3, I get 4/5, 4/5, and 2/3. So just because 2 of them are doesn't mean that they are similar. All 3 of the lengths given have to be in the same proportions. So we're going to say this is not similar. All right, so here's the theorem that tells us how we find the different ratios. Side ratio and scale factor are the same thing. If we want to find the surface area ratio, we just square the side ratio, or perimeter ratio. Perimeter is a length also. So any length ratio squared will give you the surface area ratio. And the scale factor cubed gives you the volume ratio. Pause it if you need to write it down. So let's get to a couple problems and then see if we can find some answers. 2 similar cones have radii of 5 and 15. What is the ratio for the volume? So if we take our side rate, or radius ratio, which is a length, and we can simplify that down to 1/3. So we have a ratio of lengths, and they ask us for a ratio of the volume, so I'm going to cube that, and I get 1/27. If I would cube this, I get 125 over 3375, but if I simplify that, I end up with 1/27. So it doesn't matter if you simplify or not. If you simplify, the numbers are just easier to deal with. We have a cone A and cone B are similar. The cone's radii is 10 and 15 respectively. That respectively means the A is the 10 and the 15. They stay in the same order. The volume of A is approximately 1047.2. Find the volume. So they give us a length ratio of 10 to 15. I'm going to simplify that before I do any cubing. Dividing by 5 gives me 2/3. To get the volume ratio, I need to cube that. So 8 is to 27. And then they tell me that the volume of A, which was the top, so we have to use the volume ratio with that number to get it. So I'm going to take 27, do my cross products, times 1047.2 and divide that by 8, and I get that the volume of the second one is 3,534.3 millimeters cubed. Always have labels. We're going to do the same with the softballs. Softballs shown are similar spheres. If the radius of the larger one is 1.9. Try to move this picture so you can see it. There we go. Find the radius. So if we have the volume ratio, and we want to find the radius ratio, we need to cube root these numbers. So I'm going to take the cube root of 1.05. Just like before, we can simplify before we cube root. So I divided both sides by pi, and I get 2.09175. And again, I'm going to leave a lot of decimal places because I don't want to have rounding error on my final answer. And then I'm going to do the cube root of the other one, 4.06, which gives me 1.5952987.
Mr. Otto?
Yes?
Are you teaching a new lesson?
No, I'm just recording.
Okay, well, can you show us so we can learn too?
Oh, it's... Sure. It's the lesson I already taught. I'm just recording it because Mr. Larson wanted a video to post. Alright, so then if we know that ratio, then we're going to set it equal to 1.9 and find that. So I'm going to take 1.9 times 1.5952987 equals, then divide that by 2.09157, and I get that the radius of the smaller one is 1.449, so rounded to the nearest tenth, it would be 1.4 inches. So you have to cube root the volume ratio to get to the radius ratio. Containers below are similar cylinders. Find the height of the, okay, so same thing, going from volume to a length. So my volume ratio, and I'm going to simplify the pi's out, simplify by dividing by 10. Then I'm going to cube root. Cube root of 8 is 2, cube root of 27 is 3. And so on this one, they give you the larger one's height, and we want to find the height of the smaller one. And cross products there tell me that I get 3h equals 12, so h is equal to 4 inches. There you go. There's the whole video. Have a great day.